This is our another question. In the previous tutorials, we have found line to ground fault. In this question, we will solve line to line fault. This is the type of unsymmetrical faults. In the first part, it's again asked the same question, positive, negative and zero sequence of the fault currents. And in the second question, it asks for the sequence currents injected by generator at bus 4. We will solve first part A. The things to take notice in this question is number 1, line to line fault, and number 2, the fault happens at bus number 2. Only these two things you need to remember while solving these type of sequence questions. This is the formula for line to line faults current. Positive current is equal to the negative of the negative sequence current, and it's 1 divided by Z Thevenin positive plus Z Thevenin negative plus ZF, that is almost 0 in every case, and this is the impedance of fault to ground. And in this type of question, line to line fault, our zero sequence current is always 0, so we will not evaluate this one. So put the values of this Z bus matrix. As you know, fault at bus 2 happen. So if you have seen my previous tutorial, you will come to know that we will take Z bus of 2 cross 2 matrix because the fault happen at bus 2. If the fault happen at bus 3, then we will use 3 cross 3 matrix. 3 cross 3 matrix means 3 rows, third row, third column. But in this case the bus is 2, so we will use second row, second column, second row, second column. This is already 0. So ID, I will put the value and I will come back to you. After putting the values, positive sequence is minus 3.42 iota, and negative sequence is inverse of this, I mean 3.42 iota, and zero sequence is already 0, as I told you. So in the next portion we will solve the second part exactly same as we solved for line to ground fault. Nothing will be changed. So I will solve that portion and I will just have a quick review of this for your understanding. So guys, I have solved this question. Here I don't know where I was, so let's revise quickly. We have solved this question, this portion number A. We have found the faulty positive and negative sequence currents for line to line. Now we have to find the currents at generator feeding to bus bar 4, and we have a fault at bus bar 2. I just draw this circuit for my own understanding. So we have to find the voltages at bus 4 if we want to calculate the current at bus 4. So we have to write down the formulas. It's very simple. Only the positive has 1 plus minus sign of current with reactance, and negative and 0 has exactly the same formulas. We have to find I of generator. positive, negative and zero sequence. Reactances are already known and we have to find all these values. All these are post fault voltages. All these values are, so we have to find voltages. For post fault we know that pre-fault plus del V. This is for positive, and for negative sequences del Vi. Simply there is a pre-fault only for positive and negatives are also del Vi. So we have to find del V, del V, del V of all three sequences. For voltages we know that V is equal to IR and resistance in this case is impedance. So we will find a minus sign of current with impedance. Here you have to note one thing, that here we are taking reactances that is given in the question, and if you are finding the delta V, then we are taking impedances, not reactances. This point you should remember. So fault occurs at bus bar 2 and we are considering right now the bus bar 4. So you have to take the matrix second row fourth column or fourth row second column. It is exactly same. You can take 2 cross 4 or 4 cross 2. In my previous tutorial I told you have to stick with some specific rule regarding this point, but it is flexible. You can take 2 cross 4 or 4 cross 2. You can see in the matrix the value will be exactly same. So in the given question we have second row fourth column or fourth row second column, the value is 0.007 I. By using calculator we will find this one. Similarly, negative sequence and zero sequence is already 0 because we are supposing we are given I 0 is equal to 0 for the case of line to line. So we find this parameter by putting this value positive, negative and 0 in this equation. We will find this one. So we put all these values in our required forms and we will find positive, negative and 0 sequence. Here if you are putting values you have to take one thing very important, that V4D in this case is 0.02633. I have put here, sorry, point V4D is 0.9737 because it was added with 1, is equal to 1 plus IGD minus IGD. We have to find XD is given 0.1, but here you have to write 0.1 iota, very important. And then by using the calculator you will get generator current of positive sequence like this one, negative sequence this one, and zero sequence is already 0. It's not done yet because in the sequence currents we see that there is a transformer after bus bar 4. I mean between bus bar 3 and 4 there is a transformer. So we have to consider the phase shift also at a very last step. So how we can take the phase shift, let me tell you in the next page. For your understanding I have drawn this diagram for the phase shift of the transformer. You can see the fault happens at bus 2 and then it is connected to the bus 1. Bus 1 is connected to bus 3 and then there is a transformer and we are taking bus 4 right now. I mean bus 4 is under consideration and bus 2 is our reference bus. So from bus 2 the next bus is bus 1. There is a phase shift of 30 degree, we already know. And from bus 1 there is bus 4 or bus 3 and it's a phase shift of 30 degree. So bus 2 is our reference bus. You can say that from bus 2 to bus 4 we are covering minus 60 degree distance. So in this case our value would be minus 60 by 180 pi for the positive sequence, and for negative it would be simple 60 by 180 pi. I will solve this one for you and I will come back to you. Okay, you can see that for the positive sequence we have the current exponential of minus 60 as I already explained, and for negative sequence it will be plus 60. So put the value of IGT, just take note of iota sign, it is very important, otherwise your all the values will be changed. Cos minus theta plus j sine minus theta. This 1.0472 is just the simplification of 60 divided by 180 multiplied by pi. You will get this value minus 0.22 minus 0.13 iota. Similarly, for negative sequence, you put these values by using the calculator, you will find directly this value. I hope this helps. Thank you.